This is John Black, Super Chemist. This video is from a playlist called New Updated Gravity, part 14. But this individual video is a part 2 of a subject about the life cycle and the death of our universe. In the last video, we were saying how all the dark energy is going to separate all the galaxy clusters, and sooner or later, all the galaxy clusters are going to be outside of the observable universe. And there's only going to be one cluster left in the observable universe. The more these cluster galaxies move away, even though they're outside of the observable universe, the more dark energy you have, meaning the more anti-gravity. So you're going to end up with one single galaxy surrounded by black holes, because each of these galaxies are going to be gobbling each other up, forming black holes, and the lucky one galaxy that's left is going to be surrounded by a bunch of black holes, and they will all combine to be one black hole. You'd have your whole observable universe with one giant super massive black hole in the center. And this would be the same. Remember those galaxy clusters that were moved away because of dark energy, anti-gravity? All those clusters are going to do the same thing. They're going to, at the end up being one giant super massive black hole. They say that these black holes will evaporate, or this massive black hole will evaporate. I don't believe that anymore. I don't know, but I want you to know that what I'm saying from now on in this video, like so far I've been telling you what's happening is true. Now I'm going into I'm guessing, I'm talking out my ass, I'm giving an educated guess, that kind of thing. This right here, when you get to this part right here, you have your supermassive black hole. Like I said, you're going to have a mini Big Bang. Why do I think that? It's just a total guess. Because if you have this supermassive black hole, and these other supermassive black holes keep moving away, that means the dark energy is going to get more and more and more. You're going to be crushing this super black hole forever and ever and ever, more and more and more and more and more. You can't crush it forever. I mean, if you keep adding more and more gravity to it, or anti-gravity in this case, you're going to come to a point, at least my belief is, there's a critical point where they're just going to crush it so much, there's going to be so much energy that it's going to force a mini Big Bang, because it's going to turn a lot of that mass into energy, like instantaneously, like a reaction, and that is going to set off your mini Big Bang. Again, this is just a guess. We're in the guess part of it. Part 2 is guessing. But it sounds logical, because you're going to keep just keep smashing this thing together. It's going to turn some of that mass into energy sooner or later if you keep building up the gravity. So let's say you have this mini Big Bang. Now you have a universe, a observable universe, but that observable universe doesn't have the same amount of mass that the original one did. Because remember, all those cluster galaxies moved away. They moved out of the observable universe, and you were left with only one cluster of galaxies. And that's what your whole observable universe is made of now. It's only that one cluster of galaxies that made it. And all those other ones, those clusters that went away, they're doing the same exact thing. So they're having little mini Big Bangs too. And then the same thing happens after the mini Big Bang. You spread out all your matter, and it stops accelerating due to this explosion, this Big Bang, but it keeps continuing to accelerate because of the dark energy, the anti-gravity. And the same thing will happen. The more mass will move away. You'll form clusters of galaxies, and the one galaxy will survive, and then they'll turn into black holes, and then it'll turn into one big giant black hole. And you'll have another mini Big Bang after this gets more and more anti-gravity, because everything, you're having more and more empty space around it. That energy is going to turn some of the mass into energy, and you're going to have a mini Big Bang. This just keeps happening over and over and over again. And each time that you make a new observable universe, your new observable universe is less mass, because all your other clusters of galaxies leave before this one turns into a single black hole, and then makes another mini Big Bang. Now, this is another guess here. So let's think about it. You have these universes that keep getting smaller and smaller and smaller, and they get spread out. That's why they get smaller, because they divide up. Some move this way, some move that way, some of the clusters of galaxies this way, this way. So you have different universes. But the universes are all getting smaller and smaller and smaller, which means the empty space-time that's in your area is more and more and more and more. You're building up more and more and more energy. And when you, my guess is when you have so much space-time that is empty or has so little mass, like these little Big Bangs, after you have so many little Big Bangs, you're not even going to have enough to make multiple galaxies. You're just going to make one galaxy after you do your mini Big Bang. It's going to get smaller and smaller and smaller. But when you have this little bit of mass all spread out so much, you have so much energy in the space-time itself that you just automatically get a quantum fluctuation that is so big that you create an observable universe where you create not a mini Big Bang, now you're creating a real Big Bang. The Big Bang that created our galaxies. And you have a whole bunch of mass. And then the cycle continues again. Everything expands. You're left up with one galaxy, turns into a big black hole. You have a mini Big Bang, but you have less mass now. And then you start to cycle again until you have so little mass and so much space that the energy causes a big Big Bang, not a mini Big Bang. And it's just a cycle over a cycle over a cycle. Now, if you could see a million of these observable universes, like this part right here you could see, and this part over here you could see down here and up on the top you could see, and you could see a million of them going one way. And, like to make a square, 1 million observable universes going one way and a million going this way. You can see all of them. You would see that this big, not the mini big, well, both. You would see the big Big Bang that creates an actual giant universe like we live in is happening all the time. You just can't see them because they're so spread out. And this cycle happens with those galaxies, those universes that are created out of quantum fluctuations. And then those big giant universes go through this whole process and then do the mini Big Bang process until there's just so much empty space that, and there's no mass hardly, that it's forced because you have all this energy in this space-time frame of reference that you just cause a quantum fluctuation again and you create a massive big Big Bang, not a mini Big Bang. But this is happening all over the universe. We just can't see it because you need a lot. You need a lot of energy. You need a lot of empty space to be able to see one quantum fluctuation creating an entire universe, and another quantum fluctuation way over here creating a not mini Big Bangs, but actual quantum fluctuations creating a whole universe. They're so far apart because you need so much energy to do that. That's a lot of mass to create. And so you need the space-time to hold a lot of energy. So you need a lot of empty space-time to get that quantum fluctuation to happen. But this quantum fluctuation creating giant universes, meaning a big Big Bang, they're happening all over the place. We just can't see them. The mini Big Bangs, they're happening all over the place too. We just can't see them because all we can see is our little tiny observable universe. Now again, let me stress in this video, all the way up to this part where I said the entire universe turns into one single black hole, and then dark energy keeps getting more and more, the anti-gravity gets more and more and more compressing this black hole. Anything before that was good. Anything after that, keep in mind, I'm guessing, totally guessing, but it just seems to me, if you have a black hole, you keep giving it more and more and more and more gravity, sooner or later, you're going to turn a lot of that mass into energy. And if you do that, you have a whole cluster of galaxies that form this black hole. That's a lot of mass. Now you're adding all this anti-gravity, meaning more energy, compressing it, more force. it has no choice in my mind except to turn some of that mass into energy. And we all know what happens when you turn mass into energy. We make little, 11 grams or what of plutonium or whatever it is. It's not much to make an H-bomb, an A-bomb. And we're talking about multiple galaxies being confined into a black hole. And we're going to change a big fraction of that energy, a big fraction of that mass into energy. Can you imagine that H-bomb? That's not going to be no little thing. Why wouldn't it turn the mass into energy and have a big bang? Why wouldn't it? Is it just going to keep getting this anti-gravity, this pressure more and more and more, and nothing's going to happen to the mass? That's insane. That's not going to happen. It's going to turn it into energy. It's going to make a mini Big Bang. The next video, I'm going to go over Michelson-Morley experiment. A lot of people think that experiment discounts what I'm saying. It does not. The Michelson-Morley experiment does not prove that space-time is static. It proves that it is not a river, that it flows through the entire universe in one direction. That's what it proved. Okay, it didn't prove that space-time was static. It proved it was not a river that flows. That's what ether is. It flows like a river through the entire universe. I'm not saying that. None of my videos do I say that. That's stupid. It makes no sense. But everyone wants to say that Michelson-Morley experiment proved that the space-time is static. No, it didn't prove that. You're a liar. You're just adding on what you want. Your wishes. You're manifesting things. You're adding your biases to your opinion.